Welcome back, everybody. So we got this warm up here. If you're playing along at home, pause and then play whenever you're ready. So again, we just said this is set up for substitution because one of the variables is already solved for. This y is equal to negative 8x plus 2. So what we're going to do is we're going to take out y from the second equation, and in its place, we're going to put negative 8x plus 2. Now be careful here. This is a little bit of a weird one because when I go to put that in, honestly, if I don't use parentheses, because there was no number out in front of y, I mean, that's not that big of a deal. Just make sure you don't get too tripped up on this. What is 2x plus a negative 8x? Oh, I forgot my equals negative 10. Negative 6, yeah? That's the only weird part to this one. Even if you did put it into parentheses, you'd still do the same thing because there's nothing to distribute. Yeah.
I just got rid of the plus sign and just put negative 8.
And that's what I would probably do. Just put like minus 8x plus 2. All right, now let's keep it going though, because now it turns into this simple two-step. So negative 6x is equal to negative 12 divided by negative 6. So x is 2. Sorry for my poor handwriting. And now x is 2, and we plug this in here. Y is equal to negative 8x plus 2. I'm going to say y is equal to negative 8 times 2 plus 2. Negative 16 plus 2 is negative 14. 2 comma negative 14 is my solution. Okay. If you still didn't know how to do that, if you were really stumped on that, now I'm not saying like, oops, I made a little sign mistake. That happens from time to time. But if you were like, oh man, I don't know what to do, you need to go back and you need to rewatch some of those videos again, because by now we should have understood it. All right, so let's get to it. What questions do we have out of the homework that we'd like to talk through or go over?
Oh, number 5.
Number 5? Which one did you need, Brianna?
I was going to say 5. There's another one though.
Okay, let's do 5 first, and then we'll pick up with the next one. Now, because they're both set equal to y, this is the special case where I can say 2x is going to go right into there. So I basically set them equal to one another. 2x is equal to 1/2 x minus 3. And now when I subtract the 1/2 x over to the other side, 2 minus 1/2 is 1.5, right? So I'm going to put it as a decimal right now because guess what? That decimal is going to go away right now. Negative 3 divided by 1.5. Yeah. So negative 2. And then we plug it back in. Y is equal to 2 times negative 2, which is negative 4. Negative 2 comma negative 4. What other questions do we have? Number 1. So let's go in for number 1 and just plug it in. The negative 3 is the x. So let's go equation 1 first. So this is, y is equal to, so 1 is equal to negative 1/3 times negative 3. So that is negative times a negative is a positive. 1/3 of 3 is 1. So that checks out. Equation 2, 4 times the y value, which is 1, plus 12 is equal to 3 times negative 3. All right, 4 plus 12 is 16, but that's only negative 9. That doesn't check out. That makes sense?
Mm-hmm.
So we would say no, that this is not a solution because the second equation does not check out. Yeah. 2, same thing. Plug the, let's go top equation here. Negative 4 minus 2 times 2 is negative 8. Let's check that. Negative 4 minus 4 is negative 8. So that does check out. Down here, this is 4 times negative 4 plus 13 times 2. Let's see if that's 10. Now, again, I want to show you, you can just plug it in a calculator too. So we got 4 times negative 4 plus 13 times 2, which gets us 10. So this one does check out. So we say, yes, it is a solution. Make sense? Now, can you just say yes or no on the quiz? No. I need to see the work along with the solution. Yep.
So the x equation would be like the 2 comma -4, and then the y equation would be the 4y plus 13x equals 10.
I'm not sure what you mean by x equation, y equation. All I'm doing is plugging the x coordinate and the y coordinate in for the x coordinate and the y coordinate.
Oh.
Okay. For both of them.
Oh, all right. I see what you're saying. All right, I get it.
Other questions on the worksheet? Yeah, go ahead, Brenna.
7.
Number 7 on the back. Now, let me ask you this. What did you solve for? Because there's actually a couple different options, and I'll do it the way you did it.
I got.
Like, what did you do right off the bat? What did you solve for in which equation?
I solved for y.
Y in the top?
Yeah.
Yeah. That's probably the route that I would take. So I'm looking at equation 1. -3x plus y is equal to 4. All I need to do, did you just add the 3x?
Yeah.
So y is equal to 4 plus 3x. Now, here's what I'm guessing. When I went in here, did you distribute the negative? Because that might have thrown you off if you did not.
I did.
You did. So you got x minus 3x, x minus 4 minus 3x is equal to 4? Or did you say plus 3x?
I got.
Did you say,
I plugged it in. So I plugged the top one in for the. That looks all over the place.
that's okay. Well, let's just go over it then from here.
Easier.
So we got 4 plus 3x, right?
Mhm.
Now that goes in for y. This goes in right here, right? So I say x minus 4 plus 3x is equal to 4. I have to distribute the negative, and that's what is throwing a lot of people off. You've got to distribute a negative when it's a minus sign. So minus 4 minus 3x. And so x, oops, that should not be negative 4. X minus 3x is a negative 2x. Add the 4. So that's a negative 2x is equal to 8. And then when I divide by 2, negative 2, I get x is equal to negative 4. Then I plug that back in. Let's go back into this one, this bottom one here. Y is equal to 4 plus 3 times negative 4. So 4 plus a negative 12, which is negative 8. Negative 4 comma negative 8. That make sense?
I got 1.3 comma 8.
Oh, maybe you just got missed a negative somewhere with the 8. That might have been
I don't know. I worked all over.
All right, well, let's get to today's guided notes. Now, let me remind you where we're headed. We're staring at a quiz on Friday, our last quiz of the 9 weeks. Your last opportunity. Why does it feel later than that? Feels like Thursday. No, make sure we have a little extra time. Well, we still got one more section to do. Section 5.3. Okay? We still have section 5.3 to do. Section 5.3 is basically just another technique to solving systems of equations. It's called elimination. And we're going to kind of do the exact same thing that we did with substitution, wherein I'll show you what to do. I'll explain to you what to do. We'll go through a lot of problems, and then tomorrow is just for practice. We'll just practice and practice and practice. Okay? So we're solving systems by elimination now. By elimination. Just like substitution, I'm going to walk you through the steps. But it might be easier. You might understand it more once we get around to the repetition of solving them. Because, I can explain to you in words what to do, but it's just sometimes easier just to do it. But let me explain it to you in words, just in case you learn better that way. First step is we multiply one or both of the equations, and the or both, that's gonna be tomorrow. Sometimes it's not even necessary at all. We're going to multiply, if necessary, one or both of the equation by a constant. So at least one pair of like terms is the opposite. And I'm not even going to say the same anymore. I'm going to say the opposite coefficients. What does that mean? You're looking for coefficients that are opposites, like 5 and negative 5, both on the x's. 10 and negative 10, both on the y's. 7 and negative 7, both on the x's. 20 and negative 20, both on the y's. You're looking for opposites. That's our goal. Step 2, once that's completed, add, and I'm not even going to say subtract, add the equations to eliminate one of the variables, where it gets its name, elimination. And I think you guys may have seen that in substitution. You know, as soon as you plug in one equation into the other, you get one big equation that only contains one variable. At the end of that step, you should have one of the two coordinates, either the x-coordinate or the y-coordinate. At the end of that step. That's where we're at in this one. You're going to get rid of one of the variables. Add the equations to eliminate one of the variables. Third step, solve. Solve that equation. Get the x, get the y. Step 4, and step 4 is the ending of elimination is the exact same thing as the ending of substitution. Let me repeat myself. The ending of elimination is the exact same thing as the ending to substitution. What did we have? Well, we took a coordinate, we plugged it in to find the other, right? Think about our problem that we did on our warm-up. We got x, and we plug it in to solve y. We're going to do that exact same thing for elimination. So again, let's just do it. Take a look at example A. What do you notice about the y values in example A? Are they exactly the same?
No.
They are opposites. And that's what you want. Everybody take a look right here, and I'm going to highlight it for you just to emphasize. That is the goal for elimination. That is the key to elimination. If that's not happening, you need to make that happen. Okay? If this is not happening, you need to make it happen. Because watch what happens when we just add these equations together. Look at that. I'm going to put a little plus sign, put a line underneath them, and I'm going to add vertically. Now, be careful. The equations must be lined up. X has got to be on x's. Y has got to be on y's. Numbers got to be on numbers. They have to be in what's called standard form, right? Okay, what is 3x plus 1x? 4x. What is negative 4y plus positive 4y? It cancels, right? It becomes a 0. So I'm not even going to write it. What is 10 plus negative 2? 8. And look at that equation that I just created for us. That's slick. Now, you say it's way easier. This was just set up for it. Is it easier all the time? I would beg to differ. Now, I'll tell you this. If I'm asked to do any solving by systems and I don't have Desmos, I like to do elimination. Just in my opinion. But again, it all depends on the setup. Yoast, just get out now. Oh, you guys swap?
Yeah.
You get back?
Your status page got a little wound up yesterday.
What are they?
Wow.
Yeah, that one.
That's his merch right there.
Is he an optimist?
Yeah.
Wow. You can buy that. You can
No.
that's
optimism. Straight.
Oh, this one.
Oh.
Hey, your status page got a little wound up
It's not
yesterday.
fun. Don't do that.
Wow.
Yeah.
I'll leave it there.
There's some lean out of classroom. Running into our garage door.
Finally, my background back.
Don't you hook me up with
Fun
something.
times.
Yeah, but like, I need to.
Okay, and we're back.
Where's it coming from?
So we get x equals 2, right? Fuck it. We get x equals 2, and at this point, this becomes the exact same process as substitution. What do you think I do with that x equals 2? Plug it back in. Does it matter what equation it goes into? Nope. I don't know. Let's go into the top. Does it matter? No. 3 times 2 minus 4y is 10. All I did was take that 2 and plug it in for x. So 3 times 2 is 6. So 6 minus 4y is 10. I subtract the 6 to the other side. I divide by -4. We divide by -4. We had 2 visitors in like 2 minutes. So y is 1. 2 comma 1. Again, you may be thinking to yourself, man, that was easy. But it's set up for you. That's the thing. That it was set up for you. Gio.
10 minus 6 is positive 4, not negative 4.
What am I doing to myself? Okay. I was looking at the negative. Okay. Put a negative on there, kiddos. Should have been 2 comma -1. Look at you, Gio. You're keeping me honest. That's how I know he's paying attention. All right. Always. My favorite line from any movie. Favorite line. Always.
What?
Anybody know the movie?
Lord of the Rings.
No.
Oh.
It could be.
Sandlot.
Nobody knows what
Mission
It's
Impossible.
in so many movies.
Independence Day.
It's like the best line out of any of the Harry Potter movies.
Oh,
no one
I
knows
know
that.
it.
I'll watch
When
it.
Snape says always.
Oh,
Yeah, I
I
don't
know
watch
it.
them either.
Oh, you just told us it.
That's like gut wrenching right there.
What?
When Snape says always.
Say it the way
Always.
I do this all day.
That's so inspirational.
What is that?
What does that stand for? Like, does A stand for something?
Why does he say always?
He says always because.
Is it like a poem? Like
No.
acrostic?
No.
Always.
He said because Dumbledore asked him if he loved Harry's mom.
Oh. And she didn't like him.
No, she was married to somebody
Yeah.
else.
Yeah, and
Did y'all
weren't they
not
like,
watch the
wait, I
movies?
think I watched Harry Potter.
Oh,
Then
I
like,
see.
He says, "You are my mom." He know, like
Maybe, like-
Dumbledore finds out, and he was like, "Oh my gosh, she loved her."
Yeah, but
And
didn't
he
they like,
says-
didn't she love him back in the
Oh.
day?
That should
Didn't they used to go out back in
If
the day?
y'all
Back in the
confused,
day.
just watch the movie.
They did used to go out back in the day, right?
Go out back in the day. All right,
I know, they were besties.
everybody, take a look at Part B.
Besties for arrested.
I already got the equation.
Take a look at Part B there. What do you notice about your x's?
They're opposite.
They're opposites. So let's add these two equations together. So we've Noah, be quiet. So we add these two equations together. The positive 2 and the negative 2 cancel. What's 1y plus 3y? 25 and negative 13.
12.
Come on.
And now we created a really easy equation to solve. We just divide by 4. So y is 3. See, that's the end, like the end of elimination. The rest of this is the exact same thing as substitution.
This is easy.
So we say, let's go back into the top again. Does it matter? Could we go into the bottom? Sure. So 2x plus, well, y is 3, is 25. Okay, subtract the 3. 2x is 22. X is 11.
Hold on.
What's wrong?
No, I
Hold your
got that.
bathroom.
How come the bathroom floor is like sticky? Like my feet.
Brennan, what do you think that's from?
Brennan,
We
what do
don't
you
want
think
to hear that.
What?
It's not from water, Brennan.
No, it's like everywhere, the whole floor.
Well, then I was peeing on the floor.
Everywhere.
Are your feet sticky?
Stinky or sticky?
Walking like Mr. Krabs.
Oh, no.
Okay, and then we've got 11, 3 is our solution. Shh, shh. Now, take a look at the next example. Take a look at the next example. Is this one still set up for elimination? Almost. What do you notice about the x coefficients?
They're not opposites.
They're the same. Are they opposites?
No.
No. So everybody look up here. Okay, there's way too much conversation going on. This is where it starts to get difficult, and you're gonna be like, "What are we doing? How are we doing?" What does that 2 need to be
-2.
to eliminate?
-2.
It needs to be -2, right? Needs to be -2. Now, to get that to be a negative, I want to just multiply it by a negative, right? That would be great. If I could just multiply this equation by a negative, that would be great. Can I just do that? Yes, as long as whatever I do to one side, I must multiply it to the other. So all I'm going to do is take that whole equation and make it negative.
I'm just passing by.
Oh, hi.
Come on in, learn some stuff.
Yo.
The top equation will remain the same. 2x plus y is equal to -5. The bottom equation is the one that changes. And again, you can't just make one of the terms negative. If the goal is to try to make a positive 2x and a negative 2x, and I want to make that positive a negative, the whole thing, I've got to distribute that negative into the whole equation. That positive 2x has to become a negative 2x. That negative 5y has to turn into a positive 10. What the heck am I looking at? Positive 5y.
Or you could just subtract.
No, we don't do that. We don't even dare try.
Just say it's not anything different.
You know how many more points I would have to take off if I even taught them subtraction?
I'm just saying. I think it's easy.
No way.
The math teacher wore.
Yeah, you get out. You get out right now. All right, so now we can add down. Always add. Always add. Never subtract. 2x and a negative 2x cancels. 1y and 5y make 6y. -5 and -13 make my -18. And now we create a nice and easy, simple equation. We divide by 6. Y is -3. And again, at this point, one of the coordinates is solved for. It's like dominoes. Now, the y is found. We just got to find the x. So let's go back into my first equation. Again, it doesn't matter. 2x. This says plus a -3 plus y. So I'm just going to say -3. Amateur hour right here.
I remember the first time I used this board.
You know, when I first started teaching here, it's like when they first got started.
I had Mr. Walco in 5th grade.
Wait, no,
And he
Watch
had,
out, everything's
X
safe.
equals.
he had the first smart board at Lake Elementary.
Oh my
And I
god.
remember it was like, can I just touch the board?
I know, it was like crazy. I remember we didn't even, like, when I was at OU, we didn't even, like, have them.
Well, I was in Malone 3 years ago and 4 years ago, and guess what? We didn't even have them, but you know, I mean, that's Malone.
That's Malone. So my solution is -1, -3.
Monster?
Not open. Don't you drink a full Monster at 9 in the morning?
That's great.
If I did that, I would be
Like you have high energy as it is.
Yes.
You'd be like, okay, now we're gonna do like 3x plus 4. Okay. Now does everybody see this? Oh my god.
When Ms. Lucy already thinks I scream next to me, I can't imagine
Oh
me
my
on a
God.
monster.
I feel like that was a good impersonation, Mr.
It was
Scott.
Just experiment the day before.
It was not.
the marker cap.
That's
line.
possible.
Oh,
Michael
my.
Bluff line.
He does pop up with a nice cool.
All right. Let's look at look at example D here. Now, this is where it starts to get a little bit more difficult. Let me ask you this. Let me ask you this. Shh. No. What should be here to get this to eliminate correctly?
The 1.
Well, there is a 1 there already. I know what you're saying.
Yeah, no, a 3.
I know what you're saying.
3. Yeah,
A 3, right?
that's what I know.
So this should be a 3 to make that eliminate correctly, right? Okay, there is another option that I could do. What should be there to make the y's eliminate?
-2. -2.
-2, because this is a positive. This one has to be a negative. Now, so let's pick one of them. You don't have to do both. Let's just do one. Let's pick the x. We said this needs to be a positive 3, correct? Well, what do I multiply 1 by to get to 3? 3. So let's multiply this entire equation by 3. Because again, I can't just multiply one term. Now, why can I do that? Well, as long as I multiply one side of the equation and the other side of the equation by that same number, that's still okay in the math world. I've still balanced that equation.
Yeah, what is going on?
Okay, did you see how we needed to make this 3, correct?
Yeah.
To make that happen, I can multiply one of the equations so that this becomes a 3. So here, watch. The top equation is going to become positive 3x, positive 6y, positive 33. Does the bottom change at all? No, we don't want it to change. We want it to stay at negative 3x plus y equals negative 5. Now is it set up for elimination? Okay. Let's add these two equations. The x's cancel. 6 and 1 make 7. 33 and negative 5 make 28. Okay. Yeah.
If you want to solve for y, would you just do times everything by -2?
On the bottom. Yep. Exactly. See, I was going to walk through that at the end here. If I truly wanted to get the y's to cancel, I would just have multiplied the whole bottom equation by -2. Yeah, it wouldn't have made the x's cancel, but that wasn't the point. The point was to make the y's cancel so that we could solve for the x first. See, there's some options here. We divide by 7 and y equals 4. Let's plug it back in. Let's go back into my original top. X plus 2 times 4 is 11. 2 times 4 is 8. We subtract it. 3. 3 comma 4. And that is how you force something into being, force something into solving by elimination. You just multiply one of the equations to make that happen, to make this happen so that you can have it set up to eliminate. Let's do our last one.
Can we try it?
You want to try it?
I'll
Now,
do it.
here, there's two options, though. There's two options. Let's all choose which option we'd like to go with. What would I multiply to make my x cancel?
Everything but 4.
-4. Is there something I could Is there something I could multiply to get my y to cancel? Not divide. Multiply
Oh, I was
by
looking at the different one.
2. Right? Could I multiply the whole top equation by 2? Yeah, because what would that be? Would that make that coefficient? -4. Right? Or positive 4. So let's try this route. Okay? Let's go this one. Let's multiply the whole top equation by 2. And see what happens. Go for it. I'll give you like 3 minutes head start. Okay, let's get to it. So we decided we want to multiply the top equation by 2. Let's do that. That becomes a 2x, 4y, and a negative 2. Watch out. The tendency, everybody look up here real quick. Can I see eyes up here? Because I want to show you what happens a lot of the times. The tendency is you choose what number you multiply your x and y, and you forget about the constant. I have no idea why. It just happens all the time. Like you write 2x plus 4y equals, and then you end up just writing negative 1. Like just forget. Be careful of that. All right, and the bottom stays exactly the same. 4x minus 4y is equal to 20. And now we add the two equations together. 2 and 4 make 6. The y's cancel. This becomes 18. So x equals 3. Plug it back in. Let's go back into the top. 3 plus 2y is equal to negative 1. So 2y is negative 4. We divide by 2. Y is negative 2. 3 comma negative 2. Now, again, I think you guys are seeing, and in my opinion, I like elimination better. Just my opinion. Will you have to do substitution still on the quiz on Friday? Yes. Will you have to do elimination on the quiz on Friday? Yes. Are there going to be some that you can choose? Yes.
I just want you to look at this problem. It's like I did it like perfectly, like exactly how you did it.
So did I.
Like exactly,
exactly.
Not even.
The last thing that I want to show you, I know that we're done with the guided notes. Everybody take a look up here. This is your homework for tonight. Look at problem 7 up on the board. Apparently that screen is gone now. Look at problem 7 up here. I'll zoom in a little bit. Whoa, that was a lot. Well, that's 15. Where did 7 go?
It's gotta be somewhere.
There's
You can
7.
do this. You can do this.
There we go. What is weird about number 7?
It looks like they should go
Okay.
to each other. The x's or y's are lined up.
They're not lined up. Right. This is the first, we didn't do an example where it's not lined up. So what you have to do, see the bottom is fine. But on the top, and I kind of was showing my first period what to do, you got to get the x over to the left side, the 10 over to the right side. Okay? Then you can decide, okay, what do I want to multiply by? Do I even need to multiply by anything? Like, look, 5, do you have to multiply by anything? Sweet. 3, do you have to multiply by anything? Sweet. 1, do you have to multiply by anything? No. Now, let me, shh, I'm still talking. 9, do you have to multiply by anything? Yes. 11, do you have to multiply by anything? Yes. Okay. 11 is a blue problem. Do we all know what that means?
No.
You guys really not? I thought I said
Does
this.
that mean it has answers in the book?
It's blue.
It's blue. Very good. Hold on. If you listen to me, if you go to the ebook, not the PDF copy, the actual ebook on the Big Ideas website, if you go to the ebook and open it up, and you click on that blue portion, guess what happens? It takes it to your video of that exact problem.
Okay.
So take advantage of that.
It's